Falcon Heavy is a heavy-lift rocket developed and manufactured by SpaceX. It made its debut flight on February 6, 2018, carrying a unique payload, Musk's personal Tesla Roadster, complete with a Starman mannequin driver, towards an orbit around the Sun. The rocket consists of 3 Falcon 9 first-stage cores, each equipped with 9 Merlin engines, providing a total of 27 Merlin engines for the first stage. Falcon Heavy is one of the most powerful rockets in operation and can lift nearly 64 metric tons to low Earth orbit. It is designed to be partially reusable, with the ability to land its 3 first-stage cores back on Earth after launch, allowing SpaceX to recover and refurbish them for future missions, reducing the overall launch cost. Falcon Heavy can perform various mission profiles, including satellite launches for commercial and government customers, interplanetary missions, and crewed missions to the International Space Station. The Soyuz spacecraft is a series of Russian spacecraft developed by the Soviet Union and later maintained by Russia's space agency, Roscosmos. It has been in continuous use since the early 1960s with over 1,900 flights and remains one of the world's most reliable and widely used spacecraft for crewed missions. The Soyuz spacecraft is a crucial component of Russia's human spaceflight program and has been used to transport cosmonauts and astronauts to and from various space stations, including Mir and the International Space Station. The current version of the Soyuz is the MS spacecraft. The MS stands for Modified Systems, with many smaller technological upgrades to make the spacecraft lighter and more modern. Soyuz missions have carried out various historic events, including the first human spaceflight by Yuri Gagarin in 1961 and numerous long-duration stays on space stations. Delta IV Heavy rocket has been developed by United Launch Alliance in the USA and stands approximately 70.7 meters tall. The rocket is designed to carry large and heavy payloads into space, including large communication satellites, national security payloads for the US government, and interplanetary missions like the Parker Solar Probe. It has a 3-core configuration and features a unique design with 3 common booster cores strapped together. This configuration provides additional thrust for lifting heavier payloads. The Delta IV Heavy is equipped with a 5-meter diameter payload fairing that protects the payload during the initial phases of the launch and is jettisoned once the rocket reaches space. The rocket's main stage is powered by a single RS-68A engine, which is the first large liquid hydrogen/liquid oxygen engine developed in the United States in decades. The Delta IV Heavy has been used for critical national security missions, including launching classified payloads for the NRO and other defense-related agencies. Falcon 9 is a reusable, 2-stage rocket designed and manufactured by SpaceX for the reliable and safe transport of people and payloads into Earth orbit and beyond. Falcon 9 is the world's first orbital-class reusable rocket. This allows SpaceX to refly the most expensive parts of the rocket, which in turn drives down the cost of space access. It is a 2-stage rocket. The first stage provides most of the thrust during liftoff and is responsible for the rocket's reusability, while the second stage carries the payload into orbit. The rocket has different variants with varying payload capacities. The standard version can carry up to 22,800 kilograms to low Earth orbit and around 8,300 kilograms to geostationary transfer orbit. SpaceX's ambitious Starlink project aims to provide global broadband internet coverage using a constellation of satellites launched atop Falcon 9 rockets. While primarily designed for Earth orbit missions, the Falcon 9's technology has contributed to SpaceX's plans for eventual crewed missions to Mars under the Starship development program. Arianespace's Ariane 5 is the world reference for heavy-lift launchers, capable of carrying payloads weighing more than 10 metric tons to geostationary transfer orbit and over 20 metric tons into low Earth orbit. Ariane 5 is known for its capability to launch multiple payloads simultaneously. It can carry 2 large satellites or spacecraft into space on a single mission, reducing launch costs for customers. It is a 2-stage rocket. The first stage is powered by the Vulcain 2 engine, while the second stage is powered by the HM-7B engine. The Ariane 5 uses 2 solid rocket boosters attached to its sides to provide additional thrust during liftoff. These boosters are jettisoned after they burn out. The Ariane 5 has been used to launch satellites for a variety of missions, including communication, Earth observation, and navigation. Notably, it has launched multiple satellites for the European Galileo satellite navigation system. GSLV Mk3 is ISRO's heaviest and most powerful launch vehicle, designed to carry heavier payloads to geosynchronous transfer orbit and low Earth orbit. The rocket consists of 3 stages: the core stage, a cryogenic upper stage, and a solid rocket booster stage. GSLV Mk3 is selected as the launch vehicle for India's ambitious Gaganyaan program, which aims to send Indian astronauts into space. GSLV Mk3 was used to launch Chandrayaan-2, India's second lunar exploration mission, which included an orbiter, lander, and rover. The GSLV Mk3 is also used to launch communication satellites into geostationary orbit, providing crucial telecommunications and broadcasting services. The GSLV Mk3 can carry payloads of up to around 4,000 kilograms to geostationary transfer orbit and approximately 10,000 kilograms to low Earth orbit. The Atlas V is a powerful expendable launch vehicle designed to deliver payloads into space. It is developed and operated by United Launch Alliance, a joint venture between Boeing and Lockheed Martin. It comes in different configurations based on payload capacity and mission requirements. The Atlas V made its maiden flight on August 21, 2002, successfully launching the Eutelsat W5 communication satellite. The Atlas V uses the Centaur upper stage, which can be equipped with either a single or dual-engine configuration. The dual-engine Centaur is used for heavier payloads and higher energy missions. The Atlas V is capable of launching satellites for communication, weather observation, scientific research, and national security missions. The rocket is equipped with advanced avionics and guidance systems, ensuring precise navigation and control throughout its mission. The Atlas V has maintained a strong track record of successful launches, contributing to its reputation as a reliable workhorse for a variety of missions. The Proton-M is a heavy-lift launch vehicle developed and manufactured by the Russian company Khrunichev State Research and Production Space Center. It is one of Russia's most powerful rockets. The Proton rocket family dates back to the 1960s and has been a workhorse for launching a variety of payloads, including communication satellites, scientific instruments, and space probes. The Proton-M consists of 3 stages: the first stage, second stage, and a Breeze-M upper stage. This modular design allows for customization to match specific payload requirements. The Breeze-M upper stage is responsible for placing payloads into their final orbits. It is equipped with a highly efficient engine and can perform multiple burns to deliver payloads to precise destinations. The Proton-M is capable of launching multiple payloads on a single mission, using a payload adapter called the Breeze-KM Multiple Payload Adapter. This allows for the simultaneous launch of multiple satellites. Over the years, the Proton-M has undergone several upgrades and modifications to improve its reliability and competitiveness in the global launch market. The H-IIA is a family of expendable launch vehicles developed and operated by Mitsubishi Heavy Industries to deliver payloads into various orbits, including geostationary and low Earth orbits. The H-IIA comes in several variants, denoted by a numerical suffix, indicating its payload capacity and configuration. For instance, the H-IIA-202, H-IIA-204, and so on. The H-IIA has established a reputation for reliability, with a high success rate in its launch history, contributing to its popularity among satellite operators. The H-IIA's first stage is powered by liquid rocket engines that use a mix of liquid oxygen and liquid hydrogen as propellants, known for their efficiency and cleanliness. The second stage of the H-IIA is designed to place payloads into their intended orbits. It uses a LE-5B engine, which is an upgraded version of the LE-5 engine used on the H-2 rocket. The H-IIA has been used for both commercial and government missions. It has launched communication satellites, scientific satellites, interplanetary probes, and more. Antares is a two-stage expendable launch vehicle developed by Northrop Grumman for delivering payloads to low Earth orbit and beyond. Antares is primarily used to launch Northrop Grumman's Cygnus spacecraft, which performs cargo resupply missions to the International Space Station as part of NASA's Commercial Resupply Services program. The first stage of Antares is powered by two AJ-26, formerly NK-33, engines, which are modified versions of engines originally developed for the Soviet N-1 moon rocket. The second stage of Antares uses a solid-fuel Castor 30XL motor, which provides the necessary velocity to place payloads into their desired orbit. In addition to resupply missions, Antares has been used for launching commercial satellites and other payloads into orbit. Antares is an example of collaboration between government and private industry to create reliable access to space. It showcases the growing role of commercial providers in space launch services.